According to Boyle's law, the pressure of a gas is inversely proportional to its volume, which means that when the pressure of the gas increases, the volume decreases. Let's look at an example. The air in a 5.00 liter tank has a pressure of 1.20 atm. What is the final pressure in atmospheres when the air is placed in an 8.00 liter tank? So in this example, we are just talking about pressure and the volume changes. So we assume that the temperature and the amount of gas are kept constant. So P1 V1 is equal to P2 V2 according to Boyle's law. The starting pressure is 1.20 atm and the starting pressure, the volume is 5.00 liters. The final pressure P2 is what we have to find, and the final volume is 8.00. So P2 will be 1.20 times 5.00 divided by 8.00. So we get 0.75 atm as the final pressure. So let's see if it makes sense. When the gas is kept in a larger tank, that means increased volume, the pressure has to go down. Let us take an example on Charles' law. Charles' law says that the volume of a gas is directly proportional to its temperature, which means that when the gas temperature increases, its volume also increases. A gas has a volume of 4.00 liters at 0 degrees Celsius. What is the final temperature in degrees Celsius needed to change the volume of the gas to 1.50 liters? So when we do calculations using gas laws, we always have to convert Celsius temperature to Kelvin. So in this question, we have to give the final temperature in degrees Celsius. First, we have to convert the Celsius to Kelvin, do the calculation, and when we get the final temperature in Kelvin, we have to convert it back to Celsius. So let's see. V1 over T1 is equal to V2 over T2. V1 is 4.00 liters and T1 0 degrees Celsius when converted to Kelvin is 273.15 Kelvin is equal to V2 is going to be 1.50 liters and we have to find the final temperature. So T2 will be 273.15 times 1.50 divided by 4.00. T2 comes to 102.43 degrees Kelvin. If we look at our significant figures, the lowest number of sig figs is 3. So we just underline up to 3 significant figures in this number. But now we have to convert the Kelvin back to Celsius. Temperature in Kelvin is equal to temperature in degrees Celsius plus 273.15. So our temperature 102.43 with three significant figures should be the temperature in Celsius plus 273.15. Therefore, the temperature in Celsius is equal to 102.43 minus 273.15. So we are going to get a negative temperature, and that is negative 170.718 degrees Celsius. We have to round off our final temperature to a number without any decimal places. So the final temperature in degrees Celsius would be 171. A sample of argon gas has a volume of 735 milliliters at a pressure of 1.20 atm and a temperature of 112 degrees Celsius. What is the final volume of the gas in milliliters when the pressure and temperature of the gas sample are changed to 0.55 atm and 75 degrees Celsius? So in this question, the variables we are talking about are the volume, pressure, and temperature. The gas law that uses these three variables in one calculation would be the combined gas law. And in this case, we assume that the amount of gas is kept constant. So combined gas law is P1 V1 over T1 is equal to P2 V2 over T2. In gas law calculations, we have to convert the Celsius temperature to Kelvin before we substitute the temperature in the equation. But when it comes to volume, we can substitute the number in milliliters or liters. So in this example, the starting volume as well as the final volume are given in milliliters. We're gonna stick to milliliters in the calculation. The starting pressure of this gas was 1.20 atm and the starting volume was 735 milliliters. The starting temperature is 112 degrees Celsius, that is 385.15 Kelvin, is equal to final pressure is 0.55 atm times the final volume is what we have to calculate, and then the final temperature would be 348.15 Kelvin. So when we solve for V2, it would be 1449.58 milliliters, which we have to round up to two significant figures because that's our lowest number of significant figures in the calculation. So V2 is going to be 1400 milliliters. Gay-Lussac's law relates the pressure of a gas to its temperature. When the temperature of a gas increases, its kinetic energy increases. Therefore, the pressure of the gas increases. Calculate the final temperature in degrees Celsius for a sample of helium gas with a pressure of 250 torr at 0 degrees Celsius, heated to give a pressure of 1500 torr. So Gay-Lussac's law is written as P1 over temperature 1 is equal to final pressure over the final temperature. The starting pressure was 250 torr. We can keep the pressure units in torr. We don't have to convert it to ATM. But the temperature in degrees Celsius, we have to convert it to Kelvin. So the starting temperature is 0 degrees Celsius or 273.15 Kelvin is equal to the final pressure would be 1500 torr over the final temperature. So T2 would be 1500 times 273.15 over 250 in Kelvin. T2 would be 1638.9 Kelvin. And if we look at our significant figures, it would be two significant figures. So we're going to underline up to two significant figures in this number. But we have to now convert the Kelvin temperature to Celsius temperature. So temperature in Celsius would be 1638.9 minus 273.15, and that would be 1365.75 degrees Celsius. Since we started with 0 degrees Celsius, which is a ones place temperature, we will give our final temperature to ones place as well. So the ending temperature would be 1366 degrees Celsius.